Good afternoon, Matt 3204. This is Mr. Moore's broadcasting again from Goose Bay. It's 3:50 p.m. No baby yet. Here's the dealio. Here's what's going to happen. If no baby comes by Friday, I think they're going to try and induce Joanne. So that means that the baby should be here at least Friday, or not before. So anytime now. Today is Wednesday, so anytime really. But hope for the best, I guess. Anyhow, let's get on to Geo. Last day you learned about rates of change, okay? So we looked at how some variable changes with respect to another variable. Heartbeat per second, heartbeat per minute, meters ran per second, distance driven per hour, any kind of thing. Now, we also looked at, say, basic situations or what you were supposed to do. Hopefully you found some stuff with your research and that, different statistics and whatnot. But you should have seen that most times rates of change, they sort of appear to be linear nature, okay? That is the most basic sort. Really, rates of change, it's simpler to look at, say, a linear example than it is to look at an example that's not linear. But anyhow, rates of change, bottom line, bargain basement, it is basically given by the slope over some interval, or the slope, the change in y, say, over the change in x, okay? So anyhow, let's take a look at, we're going to look at average rates of change right now, okay? So, an average rate of change for a function or some graph or creature is identified as you see below. What you have is x and y. We are looking at looking at the change as the function increases from a to b. We're looking at how the function changes with respect to the interval a and b. Likewise, this one here is a linear function. Let's look at, say, a nonlinear function. Well, we can do the same thing. We got interval a, b, the function y equals f of x. Simply put, we're looking at the value of our function at a and b, and we're taking the slope between the 2 points, a, b. Same thing over here. Now, you should notice that for a linear function, the rate of change is constant, right? There's no difference anywhere along this line. The rate of change stays constant. But for a nonlinear creature, the rate of change from here to here will be different, say, than if you went from here to here. Okay, because essentially you're finding the slope between 2 points. If you drew your lines like that, you know that the slope of those two lines is going to be different. So, defining, holy mac, dumb muck there. Defining average rate of change of y with respect to x, we write it as below. You see right here, x equals the change in y over the change in x equals triangle y over triangle x. Now, you may say, sir, what's that? That only means, the triangle means change in y divided by the change in x. That's all it means. Okay? No more, no less. So really what we're doing, do you remember the slope formula? M equals y2 subtract y1 all over x2 subtract x1. Well, ladies and gentlemen, look, this is really the same thing. You could say that's your x1, that's your x2. This here becomes your y1. This here becomes your y2. So a fancy way of writing your slope formula up here, change in y over the change in x, will become this creature down right here. In other words, the change in x, b minus a, over that small interval, or over the interval here, b minus a, is given by the change in y, which is your function, the value of your function at point B, f of b, minus f of a, this point right here. So you're finding the distance here, or the amount here, divided by the amount here. Same thing for a nonlinear function. You're finding the amount here divided by the amount of change here, the bottom. So we write this as the average rate of change equals the value of your function f of b minus f of a all over the interval b minus a. Same thing as saying y2 minus y1 over x2 minus x1. Essentially, all you're doing for average rate of change is you're finding the value of your slope between two given points. That's all you're doing, nothing more, nothing less. Okay? We're just quantifying it and applying it to real world examples. Now, for example below, if I'm going too fast, ladies and gentlemen, please go back and rewind and write this stuff down, okay? Now, for example, let's find the average rate of change if b is 5 and a is 2. And our function f of x is 1/2 x plus 3. Then we know that average rate of change, which I'm going to write as a rock, okay, looks like Akon, a rock, A-R-O-C, average rate of change is equal to the value of your function at b minus the value of your function at a all over x minus a. All you have to do here is plug in, well, what's b? b is 5, so you're going to have 1/2 times 5. What? Ah, I see what they did. Look, this is not correct. Do you notice that? They dumb muck, man. Okay, see these two here? These two should be changed around. Okay? It should be a 5 here. And it should be a 2 here. Look at that. That was in the curriculum guide. Okay? So, they made a mistake. Alright? We got it fixed. So, 1/2 of 5, which is b, plus 3, minus 1/2 of 2 plus 3. This is your value of your function at point b. This is the value of your function at point a. All over b minus a, which is 5 minus 2. Work this side out. You get 1/2 of 5 is 2.5, plus 3 is 5.5. Minus 1/2 of 2 is 1. 1 plus 3 is 4. All over 5 minus 2 is 3. Work that out. You get 1.5 over 3. You end up with 0.5 or 1/2. So the average rate of change for this function right here, the 1/2 x plus 3, between 5 and 2 is 1/2. Now, how else could you have seen it was 1/2? Just look at where this red arrow is pointing. What kind of function is this? It's, someone should have said linear, which means that the rate of change for a linear function is always a slope. So, boys and girlies, did we have to go through that arduous process of finding it? No. We could have said, look, the average rate of change for this function is 1/2 because it's constant, because you have a straight line. How easy was that? Easy, man. Easy, easy. Anyway, just an example to let you know how this stuff is going. So, the average rate of change is just finding how one variable changes with respect to a certain interval or with respect to another variable. Usually in the real world, we do time, we do meters, distance, and time. Okay? But not always. Now, how easy was this? Good? So don't forget, look, f of b minus f of a over b minus a, you're looking for the average rate of change between an interval or between some distance on your creatures. Next page. Now, here's what I want you to try. The first one here is kind of weird because they want you to write an expression for the average of a person's blood sugar concentration over the period from 1 hour to 3 hours after they have stopped drinking. Well, I mean, all they're telling us here is that C equals F of T. So it's going to be F of what? F of 3 minus F of 1 all over 3 minus 1. Because you're finding the average rate of change from the value of your function at 3 minus 1, 3 hours to 1 hour, and all over this. So that's the average rate of change there. Okay? I gave you that one. Why? Because it's kind of fooled up. Don't worry, be happy. Just write out this question, please. Write out this question down here. And I want you to do number 3. Now, if you need to pause right here to write down the first 2 questions, do so. So you can pause me now. Okay, you should be back. Now, I'm going to scroll down here so you can copy down number 3. So here's number 3. I need you to copy down number 3 and to complete that one as well. So, pause. Or no, you don't have to pause. We're going to be done now. Anyhow, average rates of change, a very, very, very simple concept. You're finding the slope really between 2 given points for a function or a graph. Works the same way with a quadratic, which you're going to see next day. The idea is simple but has many powerful applications. Okay? Well, that's it for today, ladies and jelly beans. If you get this done before the period is over, which I assume you will, you can go to your workbook. I'm not sure the page, but there's a pile of questions on average rates of change. Scope them out. Try those questions. You have the tools here now in order to do them. Some you might need to infer, but by all means, discuss them with each other. Just look through your book and find those. If you get those done, just simply go and look over the stuff from last day and do a little bit of review of Unit 1. Test is coming next week sometime. Alright, ladies and jelly beans, that's it from Mr. Mars, signing off.